All right, so here we go. We are back, and what I am going to do, I am just going to share my screen so we can see everything. All right, and so pretty much this is where we left off. I'm just going to let Microsoft Excel get bigger here. So we had our raw current, our raw count, our measured current, and our measured voltage. All right, so you can see as our voltage goes up, we actually are going to have, we're going to have an increase in current. So I am going to, and I would suggest you guys do the same. Let's just insert, and what I'm going to do is I'm going to say measured current, and I'm going to put this in amps. So I'm just going to say equals to, I'm going to do this and divide it by 1,000. So it's a milliamp, so I need to divide it by 1,000, and I'm just going to go ahead and pull this down. And you'll see that now we have our amps and all of this good stuff. And so if we actually remember, or let's just go ahead and graph these two, okay? So I am going to say insert. I'm going to go to scatter plot and then scatter here. And I don't want to move the title. I want to move this. You know what? I'll move it right here. And then I'll just go down a little bit. And the first thing that I want to do is I want to label everything that's associated with this. So the first column is the x-axis. It's what's going to be along the x-axis. And then the second column is what's going to be along the y-axis. So if we look at 0.14, this is the second point. This is about 0.14. So it looks like it's about in between. So you can see right here, 0.14. All right. So that's our measured voltage. Well, I'm saying measured voltage. And then you have the measured current that corresponds. Wait a minute. The measured current is 0.14. All right. And then the corresponding voltage is 0.124. So you'll see that this is the way. So the first thing that we want to do is we want to go ahead and label the primary horizontal axis. And this is going to be current. How about we just be more explicit or more specific? And let's call this measured current. And this is in amps. Okay. And let's do the same thing for the Y. This is our primary vertical. Primary vertical. Yep, yep. And let's say that this is our measured voltage. And this is in volts. Okay. So I typically refer to let me go ahead and say this is going to be the measured current correlation to the measured voltage. All right. So let's go ahead and take those points and let me right click on it and then add a trend line. And when I do that, you'll see I'm going to choose linear because it's pretty much linear. And I want to just set the equation on the chart here. And I want to set the R value for the equation. And the R value is called the coefficient of determination. When you have R squared, it's the coefficient of determination. But when it's just R, it's the correlation coefficient. I think it's the Pearson, something like that. But this is an equation. Now, this Y here is what's along the vertical axis, and the X is what's along the Y axis. So this is basically saying that Y is the measured voltage, and X is the measured current. And this value is the slope of the line, okay? This 0.8466 is the slope of the line. And then we have 0.001, that's the y-intercept. That's where this line is going to intercept. When x is 0, what is y? Well, it's 0.001. It's a negative 0.001. So, that's great. So this measured voltage is equal to this slope times the current. This is known as Ohm's law. Okay, so that means that this value here is the resistance. So that's R. Okay, so we've talked about Ohm's law. If we haven't, shame on me, but maybe we can do it a little bit later. I'm not sure, but it's Ohm's law. Just go look it up. You'll see. You'll see. So, and I'll just type it in here. Ohm's law. All right, so I should be able to check the resistance on this, and that resistance should correspond to 0.8466, like the resistance through the entire circuit. So if I'm going to try it. I'm going to switch this over to resistance. And right now it measures the voltage, but that's not where I'm going to go. Let me see. I think that I need to go over this one. Okay. So if I just go through the current, like if I just go through these two, that's basically going to be small. So let's look at this. So we have our current sensor here. All right. I should be able to turn this power source off, but we have our current sensor here. And the current sensor is going through the power source. Okay. And it's going all the way around. So if I start here and go all the way around, I should be able to get this resistance. So I will try to get this resistance. So we have this one here. This is going through the power supply. All of this stuff seems to be in parallel. Okay, it's going through the power supply, and then we have this current. Let's see. So this is going to have a little bit of resistance. This is going to have some. Which side do I need to go on? So let me see. This is coming from the power supply. And this one is going to the ammeter. Then it's coming out of the ammeter. All right. Well, let me see if I can just find it here. So that's 0.02. Let me make sure that I'm on, because that should just be ohms. So if I go here, I'm getting 1.2 ohms. That looks like that's a little bit too big. And then if I go here, I'm getting 1.4 ohms. So I'm trying to see, let me look at this. It's hard for me to see with all this stuff. Usually I have to break it down again. But we have this piece, then it's coming from the power supply. Then we have this one going to the ammeter. And then it's coming out of the ammeter and it's going back to this device. So I don't necessarily want to read the resistance going through this device. I want to read the resistance kind of like over the entire system. So it might require me to just check the resistance of each device. So let's just do it that way. So I'll start, since I'm measuring resistance with this, I'll just start here. And I'll put them back as I am completing them so that we can keep the circuit the same. So we have this first device, and I'll just put this on right here. Hopefully you guys can see me. It's our first device. All right. Is this our first device? Nope. Man. All right. All right, so I need to go through here. All right, so that's 0.4. So I'll just write this on here. And this is going to be in ohms. And I'll just call device name. And so the first one is 0.4 ohms, and this is going to be the device name is what's the device name? The device name is the current probe. All right, and then so I'm going to hook those right back. At least I think I am, if I can find them. So this was a okay. So we have this one, and I believe that it goes here because this is the positive terminal. So that's one device. And then we have our regular current. Okay. So what I'm going to do is I'm just going to take these two apart. I'm going to put this